Welcome back. So last time we ported our shaders to HLSL instead of GLSL and started using shader cross. And if you remember, I mentioned that Windows batch file is a horrible kind of language that is very annoying to work, and my idea would be to actually use Odin itself as a build script runner kind of. And this is what I will try to do now. So the idea would be to just create some kind of build Odin file, right, and write some boilerplate package build and the main, which would be a procedure that will run some script, and this will basically do the same stuff as our batch file. So run Odin compiler and run shader cross, and also optionally run executable, right? So we're gonna try using Odin as a kind of scripting language for build script, and for that we need a way to actually run subprocesses, right? Usually people use Python or maybe Node.js or some complicated build systems, and Python, for example, has this subprocess package, and Odin actually has something like this, but it's actually hidden a little bit. It's a bit awkward because currently there are two OS packages, if you remember. I mentioned it before that if you see here, import core OS, there's like OS and there's OS2. And OS2 is a kind of preview package that, unlike OS, it actually contains the process API to run subprocesses. And we will use that instead of normal OS. We will just alias it to OS, so we will pretend that we're just using the new OS package. And that one actually provides us with some nice functions. So if we take a look and search for process, there is a bunch of functions that would be interesting for us. For example, process start, which basically gives us a process that runs, right? And we can specify the command to run, the environment, we can pipe the standard IO, basically the normal subprocess API. And this is what we are going to use to actually run shader cross and Odin compiler itself. And how we use it is we need to write some kind of helper function, maybe call it exec or something. We pass the array of arguments to it, so like the command line. And what it needs to do is start the process. So process start, very easy. The command will be our command that we pass, right? And that returns us a process or an error, right? So what I like to do is actually forward the error to the caller and to propagate the error and not care about it here, because we will also call some more process functions that return the same error type. We can use this handy or return operator that will actually do exactly that. You can read about it, of course, on the Odin overview page, but it's very simple, right? So this function returns a pair of process and error, but we can say that we want to just propagate error, return, so or return, and then we can simply get the process like this, right? Yes, and we need to specify the output, and the output that is interesting for us, that would be our return code, and the error that we want to propagate. So error, that would be OS error, the same as the process API return. Now this requires a return statement because that's how Odin works. Next thing that we need to do is also wait for the process to finish. OS process wait, right? We pass the process to it, and we can also say or return. That returns the value with the final process state. So we just say state process wait. Finally, we need to close the process handle, so close. That can also return an error, so we can propagate it or return. And finally, we just return the pair of exit code and nil, in case we didn't return before. So we need to pass the process here. So this is a small helper function to actually just run the process, wait for it to complete, close, and the standard I/O, so std out and std air, will be just forwarded, like piped through the current process. So this is what we want for scripts. Now let's just create another very simple helper function to actually just run the commands. So we'll say run prot that takes the same string argument array and it doesn't return anything. What it will do is basically say code and error. It will execute the process and then just check if error is not null. So if it's there, then we just will log error f, right? We need to import the log, so maybe import core log error executing process and just print error. Maybe we also want to log some information that we actually are running this command, so running, just print out the command. And finally, if there was an error, we want to just exit this build script immediately, so we can use OS exit for that. Let's just use the non-zero return code like 1. And finally here, if the process was executed but exited with a non-zero exit code, we also want to exit right away. So what we will do here is just say if code not equals 0, then we do the same logging kind of thing. So we just paste it here and we say process exited with non-zero code, something like this, right? And now we can actually do this thing at least, right? Just run the Odin compiler. So for convenience, we maybe also want to have a variant of this run function that just takes the one string and splits it by space. So for that we will need a strings package, strings, so we can split it, right? And let's just say run str or something, so proc command will be string, and that will simply execute the run procedure and pass the splitted command string to it. So strings split cmd, something like this. And we don't really care about allocations and whatnot because it's just a script. So now we can just say run str, right? And just wrap this into quotes and run this. So now this should already work. So maybe let's change the task definition, right? So it's hidden here, but we can take a look. In VS Code we have our task, right? That currently it just runs the bat file, but we can of course change this to run the Odin build script. And for that we say Odin run, then the file name, so build Odin, and then we specify that it's just a single self-contained file, so it doesn't try to look for more files, more modules, and that's it. Actually, we can also, because this is a build and run task, what we can do is also pass additional arguments to the build script. And how we do this is just we specify this separator with 2 minuses and just specify some arguments here. So that would be one thing, and this would be the same but without the run file. So Odin run build.odin minus file, so something like this. Now we can try running that actually, right? And it seems to do something, but it doesn't print anything. And the problem is that we didn't set up the logger, because this is what is needed as well. So we say context logger, just create a normal console logger, exactly like we do in our application. And now you see we have this running, and it seems to work. Now if we want to support the run argument, we need to actually check the arguments, and for that we can use the slice module. So we say slice, and then here we say if slice contains OS arguments, if that contains run, then we simply say, well, run, and we pass the hello SDL3, which might be a good idea to actually extract into a constant. So let's do that. Let's say out. And because this is all literal compile time strings, we can easily concatenate it with a plus operator. So like this, and here we can also pass out. So now we have a script that actually compiles our Odin code and runs the game. Let's see what happens if we make some kind of syntax error in our code. If that fails with failure, yes, it shows all the errors, so this is fine. Good. The other thing is, of course, running shader cross. So what do we want to do with shader cross? Well, basically we want to look for all files in the shaders src folder and run shader cross to generate SPERV and also dxil and metal and later JSON. So basically these commands, but we want to do them kind of dynamically for every shader there. So let's write some functions for that. So basically we want to read all the files in the directory, so something like os read all directory by path, a handy method that simply returns an array of file information or an error, right? So we say content shaders src, and that requires an explicit allocator. We can just pass the temp allocator, but as I said, we don't really care about memory here. Now that returns files and an error. And of course, if error is for some reason is not nil, then we just say error reading shader sources, pass the error, and exit with non-zero code, right? And now what we want to do is basically say for each file in files, we want to run shader cross, pass the file there, and then we want to specify the format like SPV, for example, right? And maybe we can also already specify dxil and metal, right? MSL. So now we need to write the shader cross function, which should be pretty simple. Say shader cross is a procedure that takes the file, which is of the type os file info, so it's just a simple structure, and then the format, which should be our string. And we want to construct an out file. Remember, if I take a look at the build bot, this is what we do. We specify -o and then the file name, right? And we let it infer the formats and stage and everything. So let's do exactly that. Let's say out file equals, and we want to join the out folder and the changed shader file name. So let's do exactly that. Let's say file path join, that takes a base folder, so content shaders out. Then we want to take the shader source file name without the last extension, so without the HLSL, and append the format extension to it. So let's do that. For that we can of course use the strings concatenate method, so concatenate, and we can use base name, right? Then we would use dot, and then the format. And the base name is something that we can easily get using the filepath.stem procedure. So that would be file.name. And this is of course should be a slice literal. Like this. Now we can simply run the shader cross executable like this. So we say shader cross, then the file full path, so full path, then the -o argument, and then the out file. Okay, that seems to work. And you can see it runs shader cross with multiple parameters for multiple files for each file. And actually, if we take a look, we now have the metal and even DirectX shader sources, and also the SPRV sources as we had before. And it works exactly as before, but we don't need to specify the shader cross command every time we add a new shader or want to change something. So this is pretty nice, and that was not very hard, so I like it. And now we can simply remove our build.bat file. One benefit here is that this script should actually work also on Linux and macOS. One thing that we might want to do here is not add the exe extension on non-Windows systems. So maybe let's have some kind of base executable name without the exe. So something like exe hello SDL3, just like this. And then the out can simply be exe plus.exe when Odin OS is Windows. Otherwise, it can simply be exe. This when keyword is a compile time if statement basically, so this is all compile time, and this is pretty nice. That seems to work so far, and now we have all these different shader variants, and we can actually modify our application code to actually load the supported shader format. And this is pretty simple. We need to modify the supported shaders when we initializing the SDL GPU, when we creating the GPU device. So here we specify SPRV, right? But this is a bit mask, and we can also specify the XL because we compile for that, and of course the metal for Apple devices, right? This is one part when we need to do that, and another part is of course load shader, right? Because currently we always specify the SPV here, and the format is SPRV, and this is something that we want to actually do dynamically. So let's introduce a format flag, which will be SDL GPU shader format flag, so just one and not the whole bit mask. So this is a quirk of the Odin SDL bindings. We will use the format flag here. Then we need to have a format extension, right? So something like format ext, which will be just a string. So we specify it here, format ext. Now how to fill it is basically just checking for supported formats that we can get for this device. So let's say supported formats, and that's gonna be SDL get GPU shader formats, right? And we pass the device here, and then we simply check if SPRV in the supported formats, then the format is of course SPRV and the extension is SPV, right? Otherwise, if MSL is supported, then the format is of course MSL, format ext should be MSL, just like that. Otherwise, if the XL is supported, then the format is of course just the XL, and the extension is the XL, right? Otherwise, maybe we can just panic that there's no supported shader format, so no supported shader format, and then maybe just print what is actually supported here. And that's actually panic F, not panic, of course. So this should be actually mostly it. Let's see. So that seems to work. You see we are using Vulkan here, but now if we go to the initialization and for example remove this peer v, right, something like this, then it should actually run the Direct3D driver and use the Direct3D DXL shaders. And if you take a look at the log here, that is actually what is happening. So this is pretty nice. And let me maybe quickly check if it works on Mac. Alright, with macOS there are actually a bunch of issues. One of them is that depth texture format D24 UNorm is not really supported, at least on my Mac, and we will get to it in a little bit. But for now, let's just change it to something that is universally supported but ugly, which is D16 UNorm, like this. And another issue is that the generated MSL files actually have their entry point as main 0 and not just main. I'm not really sure why. I never really used metal, so maybe it's some kind of reserved keyword or whatever. So what we are gonna do is simply specify the main 0 entry point for MSL specifically. So let's do that. Here in the load shader, you see we specify the main as just a hard-coded string, right? So we can take that and just introduce a variable for that, right? So entry point, this would be a C string because we are passing it directly to the SDL API, right? Use it here, and basically here in the MSL branch we just override this with main 0, right? So entry point equals main 0. That should work, and as you see it does. Alright, back to Windows, and let's deal with this depth texture format issue. So if we take a look at the documentation for the GPU texture format, we'll see that for this usage the following formats are universally supported, right? D16 UNorm is supposed to be always supported, but also either, but not necessarily both, UNorm D24 that we were using before on Windows, and D32 float that is actually supported on Mac, where the 24 version is not supported. And this one's with S is for stencils that we don't really care. So what we want to do basically is default to this one, but also try to use one of those and test if they are actually supported or not. So we choose the best format that is possible. So let's just do that. Basically we want to change this to a variable and modify it on initialization, right? So let's do that. By default, let's use a D16 UNorm. And when initializing, just before we create the depth texture, what we want to do is basically try multiple formats. So maybe let's write a procedure for that, something like try depth format procedure that would take a format to try, right? SDL GPU texture format. And what it will do is simply check if SDL GPU texture supports format for the GPU device, this format for 2D textures and for the depth stencil target usage. If that is supported, then we just set this to the format, right? Very simple. And now we just call it for D32 float, right? If that is supported, that's nice. And we do the same for D24 UNorm, which is what we were using before, which should be enough. And yeah, maybe I should have used the actual rename functionality, but let's change that. And this is supposed to be, of course, a bit mask. Let's change it here as well, and that should work. Yes, it does. So that's it for now. Next time we will use the shader reflection functionality of shader cross to actually automatically set the number of uniform buffers and textures and whatnot without hard coding that. So stay tuned.